Hello everyone, my name is Ogeneti Drew Mamogo and you are welcome to Oxchem Academy. Now if you are new to my channel, kindly hit the subscription button below. Also like, share and of course avail yourself to the lessons so as not to be left behind. Welcome back. So in today's class, we're going to be learning or we're going to be continuing from our previous series under the topic chemical reactions. If you are yet to watch those videos, kindly check them out in my channel. They are titled Chemical Reactions, where we discuss the types of chemical reactions and exothermic and endothermic reactions. But for today's class, we're going to be learning about entropy and enthalpy. Okay, so first things first, what is enthalpy? Now, enthalpy can be defined as a measure of the total heat present in a thermodynamic system. So that is the total heat present in a thermodynamic system is referred to as enthalpy. So it is a measure of the total heat present in a thermodynamic system. Okay, and in such systems, pressure is constant. Now, enthalpy can be represented as H equals to delta E plus P delta V. Okay, so remember, as I said, enthalpy is denoted as H, and then a change in enthalpy is denoted as delta H. So E represents internal energy, okay, and then our P is pressure, V is volume. So this is a representation of what? Enthalpy. So take note, enthalpy is represented or denoted as H, and a change in enthalpy is denoted as delta H. Okay, so the SI unit of enthalpy is represented as kJ, which is joules per kilogram. So that is the unit, or the SI unit rather, of enthalpy. So kJ, which is joules per kilogram. Please take note of that. If thermal energy transfers from a system during a physical or chemical change, delta H will be negative, and this is what we refer to as an exothermic reaction. If thermal energy transfers from a system during a physical or a chemical change, remember we talked about physical and chemical changes, and we said a physical change is easily reversible while a chemical change is a permanent change. I hope you remember that. If you have not watched that video, check that out in my channel. It's one of our oldest videos under physical and chemical change. So as I was trying to explain, if thermal energy transfers from a system into the surroundings during the course of a physical or chemical change, delta H will be negative. Okay, so delta H will be negative if thermal energy is transferred from a system into the surrounding. Okay, and this is what we refer to as exothermic. Remember, in our previous video, we talked about exothermic and endothermic reactions, and we said that an exothermic reaction involves the release of heat from a reaction into the surroundings. Okay, so if thermal energy is released into the surroundings during a physical chemical change, your delta H becomes negative, and it is what? Exothermic. The same holds true if thermal energy is absorbed from the surroundings into the system. Okay, so the reaction, the delta H would be what? Positive, and the reaction will be endothermic. So endothermic is when the system absorbs heat from the surroundings. Okay, so it absorbs, so it is what? Endothermic, and delta H becomes positive. So please understand this key difference. So we have different types of enthalpy. We have enthalpy of reaction, we have enthalpy of combustion, we have enthalpy of solution, we have enthalpy of neutralization, we have enthalpy of formation. So these are just some of the examples or types of enthalpies that we have. Do well to make research under these types of enthalpy, read up on it. Okay, but this is what we have under enthalpy. Now moving on to entropy. What is entropy? Entropy can be defined as the degree of randomness or disorganization of a system. As I said, entropy can be defined as the degree of randomness or disorganization of a system. So this is what we refer to as what? Entropy. So how disorganized or how random a system is what we refer to as entropy. So take a liquid. We have states of matter. We have the solid state, the gaseous state, and the liquid state. So when we look at the solid particles, they are closely packed and tight together, when we look at the liquid particles, the particles have a bit more space for movement. But when we look at the gaseous particles, we see a lot of randomness. Okay, so in the gaseous particles, we see that a lot of them collide with one another and with the volume of what? The container. So it's a lot of random movement when we look at the gaseous phase of what? Matter. So this is where entropy lies. So like I said, entropy can be defined as a degree of randomness or disorderliness of a system. So entropy can be denoted by the letter S. Remember, we said for enthalpy is denoted by H, and a change in enthalpy is what? Delta H. But for entropy, it is denoted by S, and a change in entropy is denoted by delta S. So when we say delta, this is the sign that we are talking about, okay? Delta. So it kind of looks like a triangle, delta S or delta H. So delta H is used to denote enthalpy, while delta S is used to denote entropy. One thing you need to take note of is that the greater the randomness, the greater what? The entropy. So the lower the randomness, the lower the what? Entropy. So when we talk about types of entropy, we have entropy of fusion, we have entropy of vaporization, we have entropy of sublimation. So these are just examples or types of entropy. So I hope I've been able to understand the difference between entropy and enthalpy. So just as a quick recap, we said that enthalpy can be defined as the measure of the total heat present in a thermodynamic system, with pressure being what? Constant. And for entropy, we said that entropy can be defined degree of randomness or disorderliness of a system. So please don't mix these two up. In our next class, we're going to be taking calculations under entropy and enthalpy. See you there.